Hi and welcome. I hope everyone is okay. Now, in this lesson, we will learn uh, using the Z table, and we will make some practice about finding the finding the probability of some values. As you remember, in the last lesson, we worked on the normal distributions properties, and we learned the normal distribution parameters. If the random variable x is normally distributed with mean nu and the variance is sigma square, then its equation is like that. For all real values of x, this function and also all normal distributed values uh, is found by Frederick Gauss. Gauss is a German mathematician, and then he found this function. And as you see in the this function, the notation is exp. Exp means the fx function is 1 over sigma the square root of 2 pi, and e is Euler constant, and negative x minus nu square over 2 sigma square. As you see, this function is very hard, and this function this function belongs to normal distributed functions. And then if you want to find the probability of some interval, for example, normal distributed function, as you remember, this the symmetrical curve. And if you want to find the probability of from a to b, or the interval of a and b, you have to use the function of this curve, and you have to use the integration. And the probability of a and b means x greater than a and less than b, and we can say the integration from a b and fx dx. But to find this integration very hard, so we have to use some things, and it must be very easily. And at this time, we can use the z table, z values, which is transforming from x to z. And if your function and there are clearly an infinite number of values for the parameters of a normal distributed random variable. Nevertheless, most problems can be solved by transforming the random variable into a standard normal variable, which is denoted by z, and which has mean 0 and variance is 1. And then we can say that z is normal distributed, and then the first one nu is 0, and then the second one variance is 1. If you write 0 instead of nu, if you write 1 instead of sigma square in the this function, you can simplify simplify to this function, and we can say phi z. And phi z is now very short and very clearly. and we the graph of phi, as you see the right of the side, is this curve. Okay, and then if you want to find, like for example the probability of from 1 to 2, you have to write in this function z less than z less than 2 and more than 1, and you can find probability from this function. And if you want to find this probability from 1 to 2 and phi z and dz, but also to also calculating the integration very hard. So mathematicians found the probability of all values, also z values, and they created a table which named is z table, like that. And after this time, we don't calculate an integration. We only use this table, because this table shows us in the normal distributed the probability of all values. And this table is created by mathematicians by using this function and integration. Also, we don't integrate any we don't integrate any time for any values for finding the any probabilities. So we only use this table. And in this lesson we will learn how we can use this table, and how we can find the values, some values or probability. Okay, and then how we how do we use a z table, and how do we find phi z from z table? If you look at the z table, you can see some numbers. What does it mean, these number? Okay, and then you can see this table in this table. And if you want to find, for example, phi to 0.274, and firstly you have to find 0.2 in this z table. As you see, z table has some columns and some rows. And then firstly in the first column you have to find 0.2. 0.2 is here. And then secondly, for to find 0.27, you have to find 7. You have to find 7 top of this table, and 7 is here. And 0.2 and 7 meet this number. This number is 0.6064. So we can say phi 0.27 is 0.606 but we have to find 0.274. So for the last digits you have to look at the last column, the last column for the third digits, like for these 4. Okay, so and then you have to find 4, and then 0.2 and 4 meet 15. 15 means for the fourth figure, which means you have to add 0.6064. Also it is 0.027, and you have to add 0.0015 here, and then you can find easily 9, 7, 0 and 6, 0.6079, which is phi 0.274, 0.607, and then 9. Maybe we can find another phi value. For example, phi we want to find 1 to 1.3358, okay, or maybe 352. Firstly, we have to find 1.3, and then we have to find 1.35, and we have to look at column, and then we can access the result. And I want to show the Z table, and firstly we have to use 0.3 and then 0.5, okay, 0.35 1.35 1.35 is here, phi 1.35 and 2, 1.3 here, and 1.3 and 5 meet this number. Also as you see 0.9115, 0.9115, 0.9115, and for the last digits 2 also you have to find the last column for 2, and you have to find which number they are meeting. 2 is here, and 2 here, and this number is 3, and also 3 is the fourth for the fourth digits, so you have to add 0.003 fourth digits. So, and then 8 and 1, 1, 9 and 0, and you can see phi 1.352 and then 0.9118. Okay, I hope you learned how we use Z table, but after questions, for the after questions, we use much time Z table. Okay, and I want to keep going for the Z. And what are the properties of the standard normal curve? Please remember that what are the features of the standard normal curve. Standard normal curve, firstly shows us the cumulative function, and cumulative function, the probability of cumulative function, also probability function, and then under the curve, the area of under the curve gives us the probability of some values. Also, the probability of all outcomes 1. So we can say the sum of the area under the curve is 1, because the sum of the probability of all outcomes 1. So we can say this area has to be 1. The graph is a symmetrical curve according to the mean 0. And as you remember that symmetrical curve and 0 is mean, and according to mean the curve is symmetrical. This area and this area has to be have to be equal. So if the area or under the curve 1, we can say this area is 0.5 and this area is 0.5. Please don't forget the area or under the curve gives us probability, okay? And the area under the curve in a certain interval gives us the probability of this interval, and we can find this probability by using z-table easily. For example, if you want to find some probability values, for example, like here, like that. If you want to find the probability of z less than 2, more than negative 0.1, you have to use phi function, and you have to negative 0.1 and 2, and you have to find or solve this area from negative 0.1 to 2, okay? And then how we can find probability, how we can find these phi values. What does work z-table? If z is normal distributed, excuse me, if z is normally distributed with mean 0 and variance 1, the table gives the value of phi z for each value of z. We find the big area from two areas that are separated, which is under the normal curve. Okay, now as you see, if you draw the normal curve and transformed curve z, z is normally distributed, and 0 and 1, and this point is 0. And for example, if you want to find phi any value, for example, if you want to find phi negative 1.51, firstly you have to find negative 1.151, and if you draw a line, from here, and this line separated this area, this curve. The first one, the big area here. The second one, the small area. When you look at the z-table, and when you find the 1.51, you can find the area of big you can find the big area here, or if I give another example, for example, you have a normal distributed and the transformed z. Z is a normal distributed 0 and 1, And for example, if you look at the Z table, and if you want to find, for example, 0.75, please remember that the middle of the curve is 0 point, and 0.75 here. And if you draw a line, these line separated two parts of curve, and you can see the big area and the small area. The big area is this red one, and the small area is the yellow one. And if you look at the Z table, and if you want to if you find the 0.75, these number gives us the red area, so the big area. Every time Z table values, Z table, the number which is in the Z table gives us the big area. Please don't forget. And also, I want to tell something about the Z table before making some practice. We have much practice about to find probability. Please notice that in the Z table you don't see any negative value. Only you can see only positive values. Why positive value? Because as you know, in the normal distributed, maybe we can want to find the probability of negative values. Why we don't see a positive value? Firstly, I want to say that the curve, this standard normal curve is symmetrical curve. So symmetrical curve, which is according to zero also. For example, if you want to find, this is 0, this is 1.5, and if you want to find the probability of less than 1.5, you have to find 1.5 from Z value. And if you want to find the probability of more than negative 1.5, here, and also you have to find positive 1.5, because the symmetrical curve is the normal curve is a symmetrical curve, and less than 1.5 is denoted the big area, and more than negative 1.5, and this area this area is equals this area, okay, equals this area. So and maybe I can tell another example. For example, we have a normal curve, and if you want to find the probability of more than 2.5 here, if you want to find the probability of less than negative 2.5, it's also this area and this area the same. So if you when you find the probability of more than 2.5 and both more than 2.5 and less than negative 2.5, also you have to use phi 0.5 because this is symmetrical curve, so it's enough. We find positive value. It's enough that we can use positive value. Okay, we it doesn't necessarily, or we don't need to negative values, negative the probability of negative values. Okay, and we have some practice. I hope in this practice you can understand easily. And for example, given that z, the normally distributed, find the probability z less than 1 to 1.274. Okay, please focus on my screen and listen carefully because I hope these 8 questions after in these 8 questions you can understand easily, and then you can solve some problems which according to normal distributed. Firstly, if you want to find the probability of z less than 1.274, you have to draw a normal curve and 0 because our mean is 0, and then you have to find 1.274, and then you have to draw a line which separated two parts our curve, and you have to think where I am looking for small area or big area. If you notice that you are looking for z less than 1.274, which is the left of the this point. The left of the this point is here, and if you draw the this part, you can see this part is the big area, and also you can find phi 1.274 because phi 1.274 gives us big area, and also I am looking for big area. And you have to look at the z table 1.274, and you have to find phi 1.274, and also first you have to find 1.2 here, and second 7, and which number they meet, they meet 0.89. I want to pick up the 0.89 yes, 0.8900, I hope 0.8900. okay, 0.8900, and now we found 1.27, and lastly we have to find 4, and this section and 4 here, and they meet 7. We have to add 0.0007 and then 7098 this section. This is the probability of z less than 1.274, 0.8907, 0.8907, 0.8907. And the other question, given that z is normal distributed, I can see, and I am looking for the probability of z more than this. Firstly, we have to find negative points here. Negative 0.758, and I want to draw a line here, and I want to determine which area I am looking for more than this point. More than this point is here, and more than this point is here. This area is big area, and also I have to find a positive 0.758, because please remember that the normal curve is symmetrical curve, and then if you look at the z table, and if you find the 0.758, you can every time find the big area. So also I am looking for the big area. So 0.758, 0.758, and I want to use another z table, 0. Phi 0.758. Okay, 0.758. And also we have to find firstly 0.7. 0.7 is here, and then 0.5, but for the column 5 is here, and 0.7 and 5 they are meeting under this number, 0.7734, 0.7734. And lastly we have to find 8 for in the last column, 8 here, and which number they are meeting. This number is 24. 24 is, we have to add 0.0024, and also 0.7758, 0.7758, and we can say the probability is 0.7758. Okay, and now we are looking for the probability of z more than 1.06. Firstly, we have to find 1.06, and then we have to draw a line, and we have to determine which area we are looking for. Z more than 1.06. More than 1.06, the right of 1.06. The right of 1.06 here. This area, as you see, this small area. If you look at the z table, and if you find the 1.06, you find the big area. So the big area is yellow area. So yellow area is the big area, and also phi 1.06. 1.06 here. Yes, we have to find phi 1.06. 1.0 is here, 6 here, and they are meeting here, and then we can say 0.8554, 0.8554, and it is 0.8554. and it is 0.8554. But we don't look for this area. We are looking for small area. And as you remember, the area O under the curve also 1. And if you know the big area, you can find easily small area. And the small area is 1 minus big area. 1 minus 0.8554, and which is 6, 4, 4, 1 and 0. It is 0.1446, and we can say the probability of z more than 1.06 here. Okay, we have one more question and then we have lots of questions. Okay, and given that z is normal distribution and standard normal, and we are looking for the probability of z less or equals than negative 1.4, and negative 1.4 is here, and you have to draw a line, and then you have to determine which area you are looking for, and less than negative 1.4, less than negative 1.4 here. And if you want to find, if you find phi 1.4, please remember that negative or positive doesn't necessary. Also, Z table gives us positive values. So 1.4 gives us the big area, which is separated two parts by negative 1.4. If I looking for phi 1.4, I can see big area. And firstly, I want to find 1.4. I want to find 1.4. 1.4, which is 1.4 here and 0 here, and 1.4 meet this section. 0.9192, 0.1, 0.9, 0.9192. Okay, but this value for big area, but I am looking for the small area, so I have to make subtraction. 1 minus 0.9192 and also 8080 and this. Okay, and the small area and the probability of this section 0.080 and 8. And we have practice. Given that z is normal distribution and like that, firstly we have to find 1.3, 1.3 here, and 1.96, 1.96 here, and we have to draw line, but this line we are looking for more than 1.3, less than 1.96, this interval. How can we find this interval? Please remember that if you find phi 1.96, you can find the big area which separated by 1.6, 1.96. And then if you find phi 1.3, you can find the big area which is separated by 1.3. If you make subtraction between this area and this area, if you subtract from this area and this area, you can find the yellow area. So we have to find phi 1.96 minus 1.13. 1.96. Firstly, we have to 1.9 and 0, 1, 2, 3, 4, 5, 6. Yes, and then it is 0.9750. 0.9750 minus 1.3. 1.3 is here, 1.30 here, 0.9032, 0.9032, and then we can say and 8 and 1 and 7 and 0 and like this. Okay, and we have only 3 question more, and we are looking for between the probability of between negative 1.9, negative 0.1, negative 1.9 here, and negative 0.1 here, 0.1 here, and we are looking for greater than negative 1.9, less than negative 0.1, and this part. If I find phi 1.9, I can see the big area which is separated by 1.9, negative 1.9. If I find phi 0.1, I can find the big area which is separated by 0.1. And if I make subtraction from this part to this part, okay, I can find this area. So I have to make subtraction. I have to subtract from 1.9 to 0.1. Okay, 1.9 here, I want to use different table. 1.9 here, 1.9 means 1.90, 0.9713, 0.9713, and phi 0.1, 0.1 is here, 0.1 also means 0.10, and 0.5398, 0.5398, and then it is 5 and 1 and 4 and 4 and 0.4415. Okay, we have a question again, and negative 0.44, negative 0.44, and 2.06, 2.06. We are looking for the probability of greater than 0.44, less than 2.06 here. Okay, if you find phi 0.44, you can find the big area which is separated by 0.44. If you are if you find phi 2.06, you can find the big area which is separated by 2.06. Okay, and please look at this section carefully. If I add up this area and this area, for example, I hope you can understand easily. I want to say for this area C. I want to say this area, red area, A. I want to say this area B. If I find phi 0.44, I can find A plus B, big area. If I find from Z table 2.06, I can find the big area, A plus C. A plus C. If I add both of them, I have A, B, A, C. And please remember that C, A plus B plus C, which A plus B plus C, the area of under the curve, and also sum their sum 1. So we can say A plus B plus C 1. Okay, firstly A plus 0.44, 0.44, 0.4 here, 4 here, 0.44 here, and 0.6700, 0.6700, and then 2.06, 2.06, 2.06, 2.0 here, 0, 1, 2, 3, 4, 5, 6. It is 0.9803, 0.9803. And if I add both, and it is 0, 3, 0, 5, and 6, and 1. But it is this section. If I subtract 1 from this, I can find A. So A is 1.6503 minus 1, which is 0.6503. And also I looked for A. Okay. Don't worry. I will solve a question, similarly question again, and this question is last question. Okay, firstly we are looking for the probability of negative 0.08, negative 0.08 and 2.04. And firstly I have to draw this line, and I am looking for greater than negative 0.08 and less than 2.04, this area. And if I find phi 0.08, I could find the big area which is separated by 0.08, and let's say this area something, this area, for example, this is A, this is B, this is C, and if I find phi 0.08, I could find A plus C. if I find 2.04, I could find the big area which is separated by 2.04. It is a plus b. It is a plus b. And if I add both, for example, 0.08, 0.0, please look at 0.0 here, 8 here, 0.08 here, 0.5319, 0.5319, and 2.04, 2.04, 2.0 here, 2.00, 2.01, 2.02, 2.03, 2.04, 0.9793, 0, okay, 0.9793, okay. And if I add this section, I have A, B, C, and then 12 and yes, and then this. And please look at A plus B plus C 1, A plus B plus C 1, and 1, I want to move 1 the other side of the equal sign. A is 0.5112. Okay. Now we made some explanation about that, and then we solved 8 questions by using the normal curve. By the way, these 8 questions, all questions where you meet in the textbook, in the exam, for all question types, excuse me. Firstly, maybe you have struggled something. Please notice that some values are boundaries equals, some values not equals, has not equals. For example, here, or they have not equals, but they are both equals. Something, they are both equal. This is equal, has equals, has not equals. I hope notice that whatever has equals or not equals, every time we solved question the samely. Why? Because the area of under the curve we have equal sign or not equal sign, doesn't matter, because this is cumulative graph, and in a cumulative graph we can't find the probability of one value. For example, this is negative 0.1. I can't find the probability of negative 0.1. I can find only the probability of interval. So only the probability of only one value every time 0. So doesn't matter we have equal sign or not, doesn't matter. Okay, I hope this video would be useful. Please and then make more practice. If you struggled some question, please ask me in school. Have a nice day. See you.